Hi everyone, this is Andy from Adaptronic, and this is a quick video on the really basics of tuning. This is not a video to teach you how to tune. There are plenty of online resources about this, like learntotune.com for example, which will go into this in a lot more detail. But this video is really to explain the real basics of it so that you can set up your car and get it set to the point where it's running, and then you can have it tuned professionally, or you can actually go on one of these tuning courses to learn how to do it yourself. It's also kind of nice to have the engine idling nicely so that you can check for leaks and rattles and that sort of thing. The most important thing that you can have while tuning is actually something that's very difficult to teach, and it's called situational awareness. This is the sort of thing that race car drivers and fighter pilots have, and the person walking down the street dropping things and not noticing just is completely unaware of. So if you're not naturally a very situationally aware person, then you need to make an active effort to be aware of things and take notice and pay attention to things while you're doing this process, because things can go wrong and cause damage very quickly, and the earlier you know about it, the easier it is to mitigate that. So some things to look out for. Number one, fuel leaks. Really important. People put on different fuel rails and injectors and that sort of thing. What you need to do then is pressurize the fuel system and check for any leaks anywhere around any of the fittings, listen for hissing sounds, all that sort of thing before you even try and fire up the engine. Secondly, have a fire extinguisher nearby, just in case. Thirdly, don't have any puddles of fuel or anything like that. Clean them up straight away. Okay, now while an engine's running, you need to make sure that the engine's healthy. So for this, there are lots of vital signs that you should continually monitor until you've got enough confidence with the engine that you feel that you don't have to. Coolant temperature is an obvious one. The engine obviously needs to have coolant in it. You need to check that. You need to watch the coolant temperature, because the first time you hook it up, you don't know if the thermofans are going to work or if the coolant temperature sensor is reading correctly. It may leak coolant out everywhere and you might not even realize if you're not paying attention. So that's a really important one to keep an eye on. Exhaust leaks is another obvious one. You can normally hear exhaust leaks if you know what you're listening for. If you don't know what you're listening for, then listen to an exhaust leak so you know what it sounds like. But if you've got an exhaust leak, then you're going to have very high temperature gases coming out at high speeds, and you need to make sure that it's not around anything that can melt or burn or catch fire. So if you've got any hoses or wiring or anything like that nearby, then you need to make sure that's adequately protected from exhaust temperature. For that matter, any hoses or wires or anything like that need to be kept away from exhaust components. Just a couple of weeks ago, I had a situation where there was an intake silicone elbow coming out of the turbocharger was about 5mm away from the exhaust manifold. And while we're at 30 psi of boost on the dyno, the hose failed because it got too hot. That's not a catastrophic failure, of course, but if the hose that had failed had been the wastegate actuator, we could have had a major problem. Or if that hose had been a fuel line, that would have been even worse. Fuel delivery. Ideally, you should be watching the fuel pressure. You should have a gauge on the rail and monitor it when you first power it up. If you don't have that, then at least you should be listening for the fuel pump. When it starts to cavitate, it's going to make different sounds, and you need to be aware of that so you know if you're running out of fuel or something like that. Because otherwise people start seeing that it's going lean, putting more fuel into the mat, when the problem is that they've actually got a fuel pressure drop. Ideally you'd measure it, but not everyone has a fuel pressure gauge, so again, it's something to be aware of. Oil pressure is another one. Many performance cars will actually have an oil pressure gauge in the dash, like the RX-7s, MR2s, and the early MX-5s have got that. If you don't have that, it's something that you probably need to watch, unless the engine's been running for a while and you're confident with the engine mechanically. Check the oil level as well, check for oil leaks. All things relate to oil. One that's not as obvious is compression. Now, when you're cranking an engine and it doesn't fire, every newt that you hear is a compression stroke. So if you've got a 4-cylinder engine that goes then it's probably okay. But if it goes then it probably means that you're losing compression on one cylinder. So it could be that there's a hole in the piston, or a ring land's been broken off, or something like that. But that should be a sign that you should actually do a proper compression test and check it. Now, when you've actually got the engine running, you should watch all the values in the gauge window in the software, because any one of them will tell you that you've got a problem. For example, the battery voltage should be moderately consistent. The RPM should not give you big spikes. It should be fairly consistent as well. If the engine's hunting up and down, then obviously it's going to move up and down, but you shouldn't see big spikes in it. You should always be logging when you're doing this so that you can review the log and see if any sensor readings were incorrect. The map reading, obviously that should show you vacuum when the engine's running. If it doesn't show you vacuum, then it means that either you've got the wrong vacuum port on the engine, your hose has got a split in it, or some other problem is causing you not to read the vacuum correctly, and you can diagnose that further. But there's no point trying to tune an engine if you don't have an accurate vacuum reading. Temperature readings also should be fairly consistent and fairly accurate. If when the engine's running, the temperature is jumping up and down by 5 degrees at a time, then you know that there's some wiring problem because the temperature simply can't change that quickly. Ideally, you should have a wideband oxygen sensor installed and configured. We recommend the Innovate MTX-L because that gives you a gauge as well, so as a human you can watch it as well as the ECU being able to see the data. And it's easier to watch the gauge than it is on a laptop screen. And we prefer the Innovate over the other ones for various reasons I've explained in another video. But just as with every other sensor, you need to be aware of the limitations of it. So an oxygen sensor reads excess oxygen from the engine. So anything that gives you a lot more excess oxygen will give you a lean reading on the sensor. So if you have a misfire, that will give you a lean reading. If you have an exhaust leak that's upstream of the sensor, then that will also give you a lean reading. A very high overlap engine, such as a very cammy engine at idle or a peripheral port rotary, will give you a leaner reading because of all the air that basically goes straight through the engine during the overlap period. And another thing that's not as obvious is if you're using the oxygen sensor in a tailpipe and it's a large diameter pipe, then at really low RPM, the pulses actually can suck fresh air back in through the pipe, which again can give you a lean reading. So don't believe the reading at idle. That'll clear up when you get to higher RPM. Again, this is where the situational awareness comes in. The engine's simply not going to need 10 milliseconds of fuel for it to idle at the right RPM. Okay, so once you understand all the things that you need to keep an eye out for, it's time to actually start the engine. If you haven't watched my video on VE tuning and all the things you need to set up first of all, including the injector type and target AFRs and the actual VE map itself, then you should do that first. So now would be a good time for me to explain what fuel and ignition maps look like. Each map is a two-dimensional table, so expresses a three-dimensional graph, where on one axis we have the engine speed in RPM, and on the other axis we have load. Now depending on what tuning mode you've selected, that load could either be map, manifold pressure, or it could be throttle position. In the software you have the option to invert the load axis because different people like to see them in different configurations. Now for the actual calculations that take the VE number from a fuel map and convert it into a millisecond value, you should watch the video on VE tuning because that explains that in great detail. But as a tuner, it's your job to get the right numbers in this table so that the actual air-fuel ratio matches the target air-fuel ratios that you've set. Now the software helps you by first of all giving you crosshairs to show you where the engine is at the moment, and if you hit the spacebar, it will jump to the closest cell to where the engine actually is. The software also shows you the current air-fuel ratio measured from your wideband sensor and the target air-fuel ratio that you've set at the moment. Now the ECU can adjust these values in the fuel map to get to the target AFR, and for more information on that you should watch the closed loop tuning video. But in this case I'm going to explain how to do it manually, because once you understand it manually, it's easy to get the ECU to do it automatically. So the numbers, first of all, are all ratiometric. So if your target is 14.7 to 1 and the air-fuel ratio gauge is giving you 16 to 1, then that means that you're too lean by 1.3. 1.3 is about 10% of 14.7. So if you've got a value of say 70 in the map, then you should increase it to about 77. Now you can do this in a number of ways. First of all, you can drag out the area that you want using the mouse or using Shift and the arrow keys. You can hit page up 7 times, that'll increase it by 7. You can right click and say add subtract percentage and enter 10% and it'll add 10% to all the values in the map. Or you can just enter 77 and that'll set all the values that you've selected to 77. The page up, page down keys change you by 1 VE% at a time. Now don't just change the point that's closest to where the engine is at the moment, change everything in that region because they're probably all going to be wrong. Engines don't change VE very much from one RPM point to the next or from one load point to the next. The VE map should look fairly flat, and that's why when we start from scratch, we start with a flat map of about 80% VE. You know, even in this map where we see a big bump here at 6,500 RPM, that's only because we're turning on the variable valve lift at that point, which suddenly gives the engine a completely different camshaft profile. This is another example of a fuel map, which is done on a fairly tame engine with standard cams, and as you can see, it's very flat against RPM and against load. Any bump that you see against RPM is due to some volumetric efficiency RPM specific change. For example, a cam starting to work, or intake resonances starting to help you or hinder you, or exhaust scavenging starting to work or not work as well. Now against the load axis, again the VE value should not change that much. Sometimes you'll find that they need to increase more with higher loads, and that could be due to lower fuel flow and you're compensating for that in the tune. At very light loads you might find that the values need to go up or down, and that's normally because the dead times aren't exactly correct in your characterization. But the map should not be bumpy. It shouldn't go up and down a lot. If it is bumpy, then you need to smooth it out. Now, once you've got the engine idling, what you should do is you should check the ignition timing. Now, there's a function in the software that allows you to lock the ignition timing so that the ECU outputs the ignition pulse at the same angle all the time. So you should set this value to wherever you have the timing marks on your engine. So if you have timing marks at 5, 10 and 15 degrees, then you could set this to 15 degrees. If you only have a timing mark at TDC, then you need to set it to 0. Using an inductive timing light pickup is the best way to do it. If you don't have ignition leads because you have a coil unplug system, then you can normally clip an inductive timing light onto the back of the coil plug, so around all the wires that go into the plug. I'm not going to go into the engineering of why this works now, but if you draw a diagram and plot out the current path, it becomes fairly obvious. If this doesn't work for you on your timing light, then the best way is to install a high tension lead between the coil and the spark plug and clip your timing light onto that lead. So to get the timing to line up, use the up and down arrows in the software, and don't put any load on the engine until the base timing is correct. Also, remember to unlock the timing in the software once you've finished this procedure. Now, where I go from here is normally I get it to idle nicely, and then I do some light load, so some medium RPM no load tuning. So for example, 3000 RPM just on gentle throttle just to hold the engine up at that RPM, and that gives me a clue as to what sort of shape the map's going to look like. Once I've done that, I normally take those values at about 10% or so at the higher loads, and then try and drive it at the low RPM. And as soon as you get some load onto it, you'll see straight away what the air-fuel ratio does, and that will give you a clue as to whether you need to add, say, 10% to all of those, or 15% to all of them, or take 5% out, or whatever. So that should give you a good starting point. And of course, if you find that under certain RPM and certain load conditions, it's too rich or too lean, then that's the part of the map that you adjust. Now, normally, most engines with standard cams are happy to idle and cruise at about 14.7 to 1, or lambda 1. At Atmo pressure, so wide open throttle for a naturally aspirated car, they normally want about 12.5 to 1, that sort of air-fuel ratio. On boost, you'll find that they will want a richer mixture than that to keep temperatures down. So for example, 12.0 to 1 at 1 bar of boost, or 11.8 to 1 at 1 bar of boost. And for anything more than that, then it really starts to become a bit more engine specific as you start to push the limits. Rotaries, for example, need more fuel than that on boost. And for more tips on tuning rotaries, see the video on our RX-7 plug-in ECU. Okay, next we're going to talk about ignition timing. This is a situation where, again, situational awareness is really important. So you need to have a good ear for knock, and a really good way to help with this is to plug a set of headphones into the headphone socket on the ECU. If you've got a knock sensor wired up to the ECU, which all of our plugins support this except for the NA-MX5 because there's no sensor on the engine, but you can always add one, then you can listen to the engine with headphones, and that will give you a really early warning if the engine's starting to knock. Now, a general rule of thumb is about 30 degrees of timing from about 3000 RPM upwards at Atmo pressure, so at 100 kPa, and take out about 1 degree of timing per PSI of boost. So at 1 bar of boost, you'd have about 15 degrees of timing. But some engines want more than this, some engines want less. High compression engines will want less timing than this, otherwise they'll ping. And some engines, the chambers are just designed so that they need more timing. So Subaru, Suzuki's 1Js and 2Js seem to want a bit more timing for some reason. So generally we say to start off with our base map because that's a good starting point. If you hear any detonation, then make sure you pull out timing at that point. Don't just pull out half a degree, pull out say 3 degrees so you've got some margin. And just like with the fuel map, make sure you pull out a fair amount of timing from the surrounding cells as well, because they're going to behave in a similar way. If you only just pull out enough timing so it doesn't knock, then as soon as you put in slightly worse fuel or the day gets slightly hotter, then it'll start to knock again. So you want to make sure that you have some margin there. Normally, 2 degrees of margin. So I'll just go over the key points. First one is that don't have any big jumps. Engines don't behave discontinuously, they're smooth things, so eliminate any big bumps. Second, make decent sized changes. Don't change by half a degree or 1% VE at a time. You change by 1-2 degrees, 5-10% VE at a time so that you can see if there's a difference. Thirdly, change big areas at once. Don't just change one cell at a time. And lastly, when you right click, there's an option there to show all the keyboard shortcuts. So make sure you read those and use them because it really reduces the tuning time. Thanks very much. For any general tuning things, it's probably best to go to a place like learntotune.com. For any Adaptronic specific questions, obviously you go to adaptronicecu.com.